This is Lawrence Wagner, Senior Hydronics Engineer for Anderson Radiant Heating. The parameters have been lost from owner to owner, which need to be understood for the proper expectations of Eichler Radiant Panel performance and comfort. This video will focus on the original design and how your understanding can vastly improve your heating experience with Radiant Panel heating. What are the specifications for the Radiant Panel system? As an example, let's take a standard original Eichler home of 1,750 square feet with an atrium, 3 bedrooms, 2 baths, kitchen, living, and dining areas. This home contains a high-mass radiant copper panel system with VAT, that is vinyl asbestos tile, as a flooring material. You shouldn't be surprised that the heat loss for this home is excessive and much greater when compared to today's construction standards. The actual calculated heat loss for this model is 64,700 BTU per hour, or a massive 37 BTU per hour per square foot. This is 3 times the average construction standard of today. It was designed for California living and temperature conditions. Now, based upon these calculations, the radiant panel system would heat the home to 70 degrees with an outdoor temperature of 32 degrees. Notice that the delta T, or the difference between the outdoor and indoor temperatures, is calculated at 38 degrees Fahrenheit. This would be achieved with a maximum floor temperature of 85 degrees and a boiler heating source of 100,000 BTU per hour. Some of the other parameters in the design are that there is one zone of control, a single 120 volt or 24 volt thermostat, a 1/6 horsepower B&G PR pump, 1-inch supply and return mains with 1/4, 3/8, half, and 3/4 inch nominal Type L copper tubing circuits of various lengths. The tubing circuits were secured directly to a 6-inch by 6-inch number 10 steel mesh, with the responsibility of the builder to lift the tubing and the wire mesh into the center of the concrete during the pouring process. Since the concrete slabs were specified to be 4 inches, the tubing ideally would be located about 2 inches below the surface. There was no rebar in the slabs. All the tubing joints were soldered and hydrostatically tested to 250 psi prior to, during, and after the pouring of the concrete. As with all Eichler construction, the requirements for slab thickness, uniformity, and tubing depth were not always met. As one could see, the boilers were vastly oversized for the heat loss for fear of not heating the home in a timely manner. It could take 8 to 10 hours or more from a cold condition to bring the home to a comfortable 70 degrees. Remember that the design employed a high mass of concrete, which takes a while to heat. This is why the best economy of operation is to set the thermostat at one temperature and leave it there 24 hours. It is very important that the boiler sizing be maintained, and when replaced, a boiler of sufficient capacity be installed as a substitute. I would like to emphasize that the equipment should be a boiler and not a tankless water heater or other hot water source, as has been previously mentioned in another video. Of course, if the home has been upgraded with better wall insulation, double glazed windows, an insulated roof, and low R-value floor coverings, a new boiler can be sized accordingly by a qualified hydronics engineer and not the contractor. The radiant panel design distributes the warmest supply water along the perimeter of the home to the areas with the greatest heat loss. The water returns to one or more centrally adjustable manifolds located in a closet, the mechanical room, or the garage. The design provides for individual room adjustment, but is meant to have all the balance valves fully open during normal operation. Simply, a boiler source provides hot water as a supply, and it is returned for reheating after the heating energy is transferred to the concrete and radiated into the conditioned space. Based on the number of tubing circuits and the size and length of circuits, a 1 GPM or gallons per minute flow rate in each circuit achieves the design conditions. This is why when replacing a system pump, one of the proper flow rate and head That is, the ability of the pump to overcome the restriction to flow because of the small tubing size is extremely important. Every day we observe pumps installed that do not meet the original design parameters, with homeowners wondering why their systems are performing poorly or one or more rooms are not heating. The B&G PR pump specified for our example Eichler home has an 18-foot head and a 30 GPM per minute specification. Improper pump sizing always leads to poor boiler performance and heating. In modern radiant panel design, smaller pumps can be used because of the larger tubing diameter with less head restrictions, and are often in the 0.3 to 0.5 GPM range per circuit. An Eichler Radiant panel is not a modern design, and original specifications need compliance. Does this mean you can't heat the home to warmer than 70 degrees? Many older folks heat their homes to 75 degrees or more if you run the system long enough. Once the home is that warm, it takes many hours for the concrete mass to cool and change the interior temperature. Most people will find that because the effects of radiant heating, as explained in a previous video, that this temperature will be uncomfortably warm and intolerable. It all depends upon your personal level of comfort. But be assured, if you pump enough radiant energy into the home, just about any temperature is obtainable if you are willing to pay for the energy cost. 1 degree difference can mean a substantial savings in fuel cost, so a digital temperature with a small adjustable differential between on and off is very important for proper control. One last note, evenness of heating throughout the home should be achievable with the Eichler design. However, there are many reported instances where some of the farther rooms can remain cooler than the rest of the house. This is due to having 3 exterior wall surfaces of heat loss and an inadequate amount of copper tubing installed at the time of construction. There is no fix for this problem except attempting to balance the flow rate to these rooms to produce more heat. Realize when you do this, you sacrifice heating in another area of the house. Only qualified hydronic technicians with a thermal imaging camera should do the balancing to ensure the best possible results, evenness, and efficiency of operation. You should now have a better understanding of the Eichler Radiant Panel System design. Please visit our website at radiantheat.net for more information. Again, thank you for your attention. This is Lawrence Wagner, Senior Hydronics Engineer for Anderson Radiant Heating, continuing our video presentations to address the Eichler homeowners' concerns about radiant panel heating system.